Welcome to this explainer. Listen, if you're gearing up for the FE Civil exam, you already know exactly how intense the preparation can be. Time is, without a doubt, your biggest enemy on this test. But today, we're not just looking at some run-of-the-mill exam topic. We're actually unlocking what I honestly consider to be the ultimate engineering superpower, and that is mastering dimensional analysis. It is absolutely the fastest way to eliminate wrong answers, save the clock, and catch critical errors before they even happen. Once you get the hang of this, it's going to completely change how you approach literally every single calculation from here on out.
Okay, let's dive into this. Here is our agenda for today. First, we'll look at a costly engineering failure. Then we'll cover what dimensional analysis actually is, followed by fundamental rules and conversions. After that, we'll walk through a stress equation example. And finally, we'll talk about how to ace the FE Civil exam. Section 1. A costly engineering failure. The Mars Climate Orbiter.
To really set the stage, we are talking about the complete and total loss of NASA's highly advanced Mars Climate Orbiter back in 1999. Think about that for a second. This incredibly expensive, highly sophisticated spacecraft wasn't destroyed by some random space debris or a freak solar flare. No, it was lost due to a completely preventable unit error that resulted in a fatal mistake in the Martian atmosphere trajectory. So you might be wondering, how in the world does a mistake like that happen at the absolute highest levels of engineering? Well, it all came down to inconsistent systems. Team A used U.S. customary units, specifically calculating thrust in pound-seconds, while Team B was over there using SI units, totally expecting the thrust data to be in Newton-seconds. And that's it. Because of this one little mix-up, the spacecraft entered the atmosphere at the completely wrong angle. This historical failure proves that checking your units isn't just some academic exercise you do in school. It is absolutely essential in the real world.
Section 2. What is dimensional analysis? Math versus engineering.
Now, what's really interesting about this slide is this specific mantra. A mathematically correct calculation is not necessarily an engineeringly correct calculation. I want you to really let that sink in. You can punch the numbers into your calculator flawlessly, but if your dimensions are wrong, the result is completely useless. Doing the math right means absolutely nothing if the physical context of the problem is broken.
So let's actually define it. Dimensional analysis is the process of verifying that both sides of an engineering equation have the exact same physical dimensions and compatible units before you ever trust that numerical answer. Basically, before you worry about the final number, you always have to ask yourself, hey, do these units actually make sense? It acts as your own independent quality control tool. And just a quick heads up here, the FE exam writers explicitly test this. They love providing numerically correct multiple choice answers that have entirely wrong dimensions, just to see if you're paying attention.
To actually use this tool effectively, we've got to distinguish between dimensions and units. A dimension describes the actual physical nature of a quantity, things like length, force, mass, or time. A unit, on the other hand, is just the measurement standard we use to express that quantity, like meters, inches, pounds, or newtons. Always remember that both feet and inches represent the exact same single dimension of length. In fact, the FE Civil exam frequently requires you to convert between different measurement standards within the exact same problem, just to test this specific concept. Section 3, Fundamental Rules and Conversions, the Engineer's Toolkit. So the crucial point is grasping these 5 foundational rules. Number 1, you can only add or subtract quantities that have identical dimensions. 2, both sides of your equation must match perfectly. 3, you multiply and divide dimensions according to standard algebraic rules. Now let's slow down for rule 4 because this is a big one. Convert your units before substituting numerical values into your formula. Skipping this step is literally the number 1 reason test takers lose time and points on the FE exam. And finally, rule 5, always verify the units of your final answer. I highly recommend grabbing a screenshot of these baseline conversions for your notes. For length, you need to instinctively know that 1 foot is 12 inches, or 0.3048 meters. For force, remember that 1 kip equals 1,000 pounds, and 1 kilonewton equals 1,000 newtons. Here's a huge FE Civil exam tip for you. While the NCES reference handbook does actually have these conversions, searching for basic ones like kips to pounds wastes precious exam time. Memorization equals speed, and speed is everything. And this brilliantly illustrates one of the absolute biggest traps you're going to face. Because area is squared length, your conversion factor must also be squared. 1 square foot is not 12 square inches, it's 12 squared, or 144 square inches. The exact same logic applies to volume, which is cubed length. 1 cubic foot is 12 cubed, or 1728 cubic inches. Forgetting to square or cube these conversion factors is a massive, massive trap on the FE exam, so please take your time with it. To quickly wrap up our toolkit, let's check out some advanced conversions. Stress and pressure. 1 KSI is 1000 PSI, and 1 MPa is about 145 PSI. For moments, remember 1 pound-foot is 12 pound-inches. And for distributed loads, converting kips per foot to pounds per inch is a super standard maneuver. You'll see this especially in water resources or geotechnical problems, where converting distributed loads is just a frequent requirement. It brilliantly anchors the general math into very specific civil engineering domains.
Section 4. The stress equation example. Putting it into practice.
Okay, let's look at a classic equation you are going to use constantly, the stress equation. Stress, which is represented by sigma, equals force, or P, divided by cross-sectional area, A. To test this equation out, let's go ahead and, to borrow a phrase from our source material, just live in the land of US units for a second.
Let's walk through this clean, successful calculation. We've got a force of 20 kip and an area of 10 square inches. When we divide 20 by 10, the mental math is super easy, right? We get 2. But more importantly, look at how the units align perfectly. Taking that kip and placing it over the square inch marries perfectly to give us a stress of 2 KSI, which is kips per square inch. Everything works out exactly as it should. But here is the trap. Imagine a situation where you accidentally enter the area in square feet instead of square inches. Your calculator doesn't care. It will gladly spit out a completely incorrect numerical result. And in a multiple-choice format, the test creators will absolutely include that incorrect numerical result as one of your options. Option A, B, C, or D is definitely going to have it. However, if you're strictly using dimensional analysis, it immediately reveals this typo because your resulting units would be kips per square foot, which you'd instantly recognize doesn't represent the KSI stress you need. Dimensional analysis is quite literally the only way to avoid picking that intended trap.
Section 5. ACE the FE Civil Exam, your winning strategy. Let's move to and see how this builds as we transition to conquering the ultimate boss fight, the FE Civil Exam.
I really want you to internalize this 5-step rhythm for every single question you face. Step 1. Identify the required unit system right away. Honestly, I highly recommend highlighting or circling the required units in the question prompt first, before you even touch a calculator. Step 2. Convert every single quantity into consistent units before you do any math. Step 3. Perform the calculation. Step 4. Verify the dimensions of your final answer. If you are ever unsure of a complex unit's dimensions during this step, immediately pull up the NCES handbook. And Step 5. Confirm you have the expected units. So many incorrect FE exam answers come from inconsistent units, not bad math. Let's rapid fire through some common pitfalls you absolutely must avoid. Do not mix SI and US units. Do not ignore your basic foot-to-inch conversions. Never, ever forget to square or cube your area and volume conversions. And never ignore your final answer units. The computer-based test is specifically designed to catch these exact rushes in logic. When test takers get stressed out and watch that clock ticking down, they rush the units. Don't let that be you. Ultimately, math just gives you a number. But will your units give it meaning? Mastering dimensional analysis empowers you to prevent catastrophic errors, not just on your exam, but throughout your entire engineering career. Make checking your units your ultimate habit, and you will always have the confidence that your calculations are physically meaningful. Thanks so much for joining me on this explainer, and seriously, good luck out there.